Hello everyone, this is our 10th lecture and topic of today's lecture is estimate for R.C.C beamwork. In our previous lecture, we already studied about the estimate of R.C.C slab work in which we have to find quantities of slab, example, concrete, reinforcement and framework. Same quantity we find for the beam. So here we consider one example for finding the quantities for R.C.C beamwork. This is our example in which we take a one beam and this is the various reinforcement bar, dia and center to center spacing are given. Here our beam is situated on wall which is 0.3 meter in width. Here we have bars 10 mm stirrups, 120 mm center to center spacing, 10 mm stirrups, 200 mm center to center spacing, 6 mm stirrups, 300 mm center to center spacing. Here our main reinforcement is 4 22 mm dia bars. Here we have 4 bent up bars, 20 mm dia bent up bars, 2 bars here and 2 bars here. This is our anchor bar or distribution bar. This is 2 in number and 12 mm in dia. So with the help of this diagram and with the help of this diagram, we have to find or estimate the quantities for beam work. This is the diagram of beam in which we have to show some bars, proper dimensions means the height of the beam, width of the beam, clear cover and all dimensions given in this diagram. So with the help of this board diagram we have to find the quantities. But before that we have to first recall our bar bending schedules means we have to find different hoop length of the straight bar, length of the bent up bars. So first we recall how we find this different straight length of the bars. So for that first we take the straight bar which is used as a main bar or as a distribution bar. So in our straight bar we have given two hooks in both sides. So we have to calculate this straight length. So for that we have one formula. Total length of the bar is equal to straight length plus 2 9 into d. Here straight length is from that point to that point. Means here L is equal to from this point to this point. We have to calculate this part also for calculating the final length of the bar. So how we calculate this? We have given this is the 4D and this length is the 5D. This is the 4D and this length is the 5D. So 4D plus 5D. Here we get total length is the 9D. So we have here two hooks. That's why here we provide 2 into 9 into D. Here D is the dia of bar. So for calculating the length of straight bar, we have to use this formula straight length plus 2 bracket में 9 into D. Now second bar, this is the bent up bar or a crank bar. We have to calculate straight length for this bar also. So here we have bent up bars. So for that we have to find this length because if we have this length, so this is equal to D. But this is the inclined part, that's why this length does not match this length. For that we have to calculate this part. In our previous lecture we also discussed that part. But that is the formula for finding this bent up length is straight length plus 2 into 0.45x. So how we get this value? We get this value with the help of this diagram. We have bent up bars. We know that this is our x. Now we have to find this length. So for that what we do? We take CD is equal to x sin theta minus x tan theta. So x sin theta, so is equal to 1 upon sin theta minus 1 upon tan theta and our bar is bent at 45 degree. If our bar is bent at 45 degree, we get x 1.414 minus 1 and final we get 0.414x and approximately we called as a 0.45x. So 0.45x is nothing, it is the length of the CD. So after finding this we get this value and we get this value divided x by tan theta or simply x because tan theta, and here theta is 45, so tan 45 is equal to 1, means this is the x. So this x is equal, only we have to add the ct part. So how we get the ct part? With the help of this formula. So this is the bars which we have found in our beam part and a slab part. So with the help of this formula, we have to calculate the length of this bar. Now in our beam, we have also used the stirrup. So how we calculate the total length of bar? So we calculate with the help of this formula. 2a plus b plus 24d or 0.15 meter. Means you have to take 24d or 0.15 meter. And here given 2a plus b. A is this length, b is this length. So here we have 1a, 2a, and here we have 1b and 2b. That's why here we multiply with 2. And this is our hoop length. So here hoop length is the 12d and 12d. That's why here we write 12d plus 12d is equal to 24d. But you also know that when we use this hoop length, when we have to find hoop length in slab case, we have used 9d as a formula. But we know that at that time we take 0.075 as a value, because maximum value is 75 mm. Below this value we not take any values. That's why we take here 0.075 mm, 0.075 meter. But here we have 24d or 0.15 meter. So now we have to go our measurement sheet. How we find the quantities for beam? So first we have to find the concrete, and the concrete for slab, here slab is not, this is the beam. So for concrete for beam is 1:2:4. Please cut this. This is not the slab, this is the beam. 1:2:4. So we have one beam, so we have to find the length of, we have to find the length and width, because we have to done concreting in our beam. So this is our length and this is our width. So simply we have to multiply this. So we have to get 8.6, 0.4 as a width, and height is 75 mm. We have given here height also. This is the height 75 centimeters. So we convert this height in the meter. So we get this value. So here we get 0.75 meter as a height, and we multiply simply and get the quantity of concrete. Now in our beam we have to provide formwork also. So for that, in our beam we have to provide formwork at bottom side, at side, at ends. We have three sides for providing the formwork: one at bottom, one at side, means both side, and one at both ends. So that's why here we take bottom and side and ends. So at bottom we have only one bottom, we have two sides and two ends. That's why here we write one bottom, two sides and two ends. Now we have to calculate the length and width and height of the different formwork. So for bottom part, we know that this beam is situated on wall. So wall, for example, this part is situated in wall. This part is situated in wall. So you have to calculate only this length. That's why here we take 8 meter as a length of beam. And we know that width is 0.4. That's why bottom formwork is 8 into 0.4. So here we get 3.2 as a quantity. Now inside we have two sides. So in two sides we have height. How much height here? 0.75 meter and 0.75 meter, and length is 8.6 meter. Why? Because this beam is situated on wall. That's why here we consider out to out length. So here we get 8.6 as a length, and height is 0.75 meter. That's why here we write 8.6 and 0.75 as a value, and we get 12.9. For ends, for these ends, means these ends and opposite side ends. So for that we have to calculate length and width. So here we get, this is the width, we have 0.4 as a width, and up to this point, means this is the 0.7 meter. 0.75 meter as a height. So we get this value 0.6. How we get 0.4 is the width and 0.75 is the height. So we get this value, and after summing this all value we get 16.7 meter square as a formwork for beam. Now we have to calculate this reinforcement, means we have these main bars, we have this bent up bars, we have this anchor bar or distribution bar, and these stirrups. So we have to calculate total weight of this reinforcement. For that we have to calculate first main bars. We have 22 mm dia main bars and the numbers of bars is 4. So for 22 mm dia we have to calculate 1 meter weight of bar. So how we calculate? With the help of d square upon 162. So d is 22, so 22 into 22 divided by 162. Here we get 299 kg per meter as a value. Now we have to find the length. We know that here our number of bars is 4. We get here 1 meter weight of reinforcement. Now we have to calculate the length. So how we calculate the length? We have to calculate length from this side to this side. So here we know that the clear length is the, means clear span is 8 meter. So we calculate 8 meter, and wall width is 0.3 meter and 0.3 meter, means total length is 8.6 meter. But from in this value we have to calculate hook value also, because we have to provide hook here and hook here. So the formula for hook is 2 9 into d. So here we provide 2 into 9 into d. But from that side we also provide cover. So in our 8.6 length, cover is also included. That's why we neglect or subtract the 8 point, sorry, not neglect, we have to subtract the cover from both sides. So we have to get 8.92 as our length. So we simply multiply this 8.92 and we get here 106.68 kg. Same we have to use for 20 mm dia bent up bars. How we find this? We have one formula for that, L plus 2 into 0.45x. Why we are provide 2 into 0.45x? Because we have two bent up bars in a single bar. That's why we provide here 2 into 0.45 d or x. So we have to calculate d. So how we find the d? D is the vertical distance of this bar. Means this is x. We have to find this. So for that first we have to find the, first we have to subtract the from total thickness. We have total thickness is 0.75 meter, or total height is the 0.75 meter minus 2 into 0.05. We have to provide cover here. So that's why in proper diameter, proper height, we have to find minus cover. Now we have to minus the stirrups dia. So we have 10 mm stirrup dia. That's why here we want to deduct 2 into 0.010 minus 0.02. Why? Because here these bars is also included, these bars. So from both sides these bars is come, and these bars we have 20 mm dia. So we have to take half from that side, half for that side. That's why here we total minus single bar. So we get 0.61 as the answer. Now L is equal to 8.6 plus and 2 into, and we get 8.88, and final we get this value. So with the help of this value we find the quantity of 20 mm bent up bars. Same we have to find the anchor bars. For anchors bars, same 12. So 12 into 12 divided by 162, we get this 1 meter bar value, and we get simply 8.74 as the length of the bar, and here we provide 2 bar as a anchor bar. So now for today this lecture is over, guys. We continue this lecture, so you have to visit part 2 of this lecture also. Thank you.